Refraction of light through a prism. To understand the refraction of light through a prism, we first learn what is prism. Prism. A prism is a piece of glass. A prism is having two triangle bases. And having three rectangular lateral surfaces. One of the rectangular surface, let's say B, C, F, E, is called base of the prism. The other two inclined surfaces, A, B, E, D, and A, C, F, D, are known as lateral surfaces or refracting surfaces. The line along these two lateral surfaces meet is called refracting edge of prism. The angle between two lateral or refracting surfaces is called angle of the prism. Any section of the prism perpendicular to the refracting edge is called principal section of prism. Now, we do activity to understand the refraction of light through a prism. Activity: refraction of light through a prism. We take a triangular prism, a cardboard, a white sheet of paper, few thumbnail pins, a pencil, a protractor to measure the angle, a ruler. Fix a sheet of white paper on a drawing board using drawing pins. Place a glass prism on it, in such a way that it rests on its triangular base. Trace the outline of the prism, using a pencil. Make its boundary, A, B, and C. Remove the prism. Draw a straight line, P, E, inclined to one of the refracting surfaces, say A, B, of the prism. Fix two pins, say at points P and Q, on the line P, E. Put the prism back on boundary A, B, C. Look for the images of the pins fixed at P and Q through the other face. Fix two more pins at points R and S, such that the pins at R and S lie on the same straight line. Remove the glass prism and the pins. The line P, E meets the boundary AB of prism at point E. Similarly, join S, R, and make this line to meet the prism boundary AC at point F. Join the points E, F. Draw a perpendicular to the refracting surfaces A, B, and A, C of the prism at points E and F, respectively. These are marked as N and M. Here, line NE is normal to surface AB, and line MF is normal to surface AC. Here, PE represents the incident ray. EF is the refracted ray, and FS is the emergent ray. Note: a ray of light is entering from air to glass at first surface AB. Here, this light ray, due to refraction, has bent towards the normal. Angle of refraction. This angle, which is bent towards the normal due to refraction, is called angle of refraction, which is denoted by angle R. And angle which is emerging from air to glass with respect to normal is called angle of incident, which is denoted by angle I. Here, you can observe 1. Angle of incident, which is denoted by angle I. 2. Angle of refraction, which is denoted by angle R. Now, we observe that at second surface AC, the light ray has entered from glass to air. Hence, it has bent away from normal. So, we get that there is emergence ray bent at an angle called angle E, equal to angle of emergence to the direction of the incident ray. If the incident ray PE extended forward to the H, and the emergence ray SF backward at K, these two ray, incident and emergent ray, meet at point G, which forming an angle FGH. Measure the angle FGH. Angle of deviation. This angle FGH is called angle of deviation. Angle of deviation is the angle through which the incident ray is deviated. Do it yourself. Please repeat this with the different position of first two pins or angle of incident.